morning, everyone. My name is Tai Jung, and here is my presentation. The topic of the paper I read is development of washing and sterilization system for leafy vegetables. And here are the authors, and it's from the EAEF journal. So why the authors focus on this topic? That's because consumption of green leafy vegetables has been increasing, such as in large restaurants or school cafeterias. However, if the vegetables are served without first washing, the dust and microorganisms will cause some toxic effects or hazardous materials accumulations. So the solution of this situation is to develop a system including washing, sterilizing, and dehydrating system. The leafy vegetables they used were lettuce, perilla, and black Chinese cabbage. They were purchased from the local market in Korea within 1 day after harvest. On the evaluation of factors on developing this system. They are washing methods, washing time, water-based sterilization methods, spin dryer and damage rate, washing system, and working performance. And here I will speak the method and the result together because I think it's more easy for us to understand this paper. There are 3 types of washing methods to be evaluated: spray, blow, and the air bubble type. The spray type has nozzles on both sides of the semi-cylindrical type water tank in which leaf vegetables were hung on the wire at the center. The blow type has holes on the pipe on both sides of the semi-cylindrical type water tank. And the air bubble type has bubbles generating holes at the bottom of the aerial bath in which leaves in a washing box are placed. The result of evaluation of washing method is at the table. The materials used in air bubble type had a list has risk remaining. Net remaining only 20%. What caused the other 2 types was not so efficient was spray type did not effectively wash the whole leaf surface, while the blow type could wash only one side of the leaf surface. And to find out the best washing time, they tried from 1 to 30 minutes. The result was for lettuce and perilla are 5 minutes, and it was the best, while for flat Chinese cabbage, it was 10 minutes. That is because the leaves of the former 2 plants are softer and easier to wash, so they cost the less time. When consider about the sterilization, they also tried 3 methods: electrolyzed X water, ozonized water, and ultrasonic. And they were generated by the machines below. From this table, we can see the efficiency of electrolyzed X water was the best, and of ozonized water was also good. This was the result of the hypochlorous X and ozone generated by those 2 methods. They oxidize the microorganisms on the leaf surface. However, ultrasonic method had a low removal effect. That was because the ultrasonic wave was observed by the soft leaves. Additionally, exposing lettuce to ultrasonic waves for more than 5 minutes resulted in water spot at the leaf ends, and which will reduce the commercial value of the lettuce. For dehydrating, they use a spin dryer as the picture shows here. And with different rotation rates, they compare the spin dry rate and damage leaf rate to select the best fit. And how they determine the red are the formulas here. As shown in this figure, the best rotation speed was 400 rpm, and it was selected because if the speed went higher, the damage rate would rapidly go over 5%, while the dehydrate rate would not increase too much. And from the results of evaluations above, they combine the most efficient method to create this system. The air bubble washing and electrolyzed water sterilization were used. And the best washing time and rotating speed were also in use. The vegetables are contained in individual boxes and pass through different stages, as shown in this picture. Here is the box, and there are the different stages. These three pictures shows the effect of different steps on removal bacteria, coliform, and foreign materials. This picture is for bacteria, and here is for coliform, and there is foreign materials. Okay, you can see each of them that has the downward tendency. However, here in the rinsing stage, slightly increase the number of bacteria and coliform. That is because of the contamination in the rinse bed. We can see after all the stages, the removal of bacteria and foreign materials can be up to 94% and 74%, while the coliform can be totally removed. Here we talk about the working performance. The working performance of a developed system is compared with manual working in this table. It was obvious that the operating capacity of the system was more than 20 times of the manual working, and the box errors were all nearby 5%, which is good for prototype. So here are the conclusions of this paper. The authors compared the performance of different types in each stage to develop a washing, sterilizing, and dehydrating system. And they found the most efficient washing method is air bubble. And the optimal washing time for lettuce and perilla are 5 minutes, and for that Chinese cabbage is 10 minutes. And the most efficient sterilization method was electrolyzed water. And the system they developed consists of air bubble washing stage, electrolytic water sterilization stage, cool water rinsing stage, and centrifugal spin dryer stage. The result, the removal rate of bacteria was 64 to 94%, for coliform was 100%, and for foreign materials it was 54 to 74%. And the system performance, operating capacity of the developed system for lettuce, perilla, and Chinese cabbage were 25, 24, and 27 times better than the manual washing method. Now above is my presentation. Thank you for your attention.
She has demonstrated very precise time control. 7 minutes, so it's very precise. Thank you. More questions and comments? Yeah.
Thank you for your excellent presentation. I have one question about the remove rate. The item you compare is bacteria and the coliform and the foreign body. So what's the difference between bacteria and the coliform? What is coliform? Is a parasite, or is also a bacteria? So why this paper choose two kind of bacteria to compare?
I think it didn't indicate, but I think it's because the storyboard is always become the indication of disease. And the bacteria is indicate other bacteria is that they celebrate these two coming.
Thank you. And one question about the washing time. Because in the figure, this paper showed as the time increasing, the bacteria still in the first day they can remove the bacteria, but as the time goes on, the bacteria grow again. So did they explain this phenomenon?
That's it, because when the longer they wash in the tank, and the water will, there are more bacteria washed in the tank, and they will attach again.
So during the wash time, they didn't change the washing fluid inside the box, all the same circle.
In one circle, they don't change the waters.
Thank you. Thank you very much.
I want to ask about the removal of the coliform. Why it can reach the 100%?
Why can you 100%? I think here didn't mention, but I think here you can see that in the sterilization stage, it was almost all sweet. So I think it's the electrolyzed water, that's water, is useful to the molecule, I think.
Thank you.
According to the first figure, in the first figure, the fourth step, the bacteria didn't decrease, instead it actually increased. Can you explain what is the reason?
Oh yeah. I said here this stage is rinsing stage, and the bacteria increases because of as the increase when working time is longer, the bacteria in the water will attach again to the vegetables.
Questions from Kyoto University?
First, I would like to give you thanks for your presentation. So I have a lot of questions. Among them, I will ask you one or two questions. We know that the killing of bacteria or any microorganism follows the master of the kinetic reaction. That means it can destroy all the organism, or it's not supposed to the zero value. It may be 99.9%. That causes D value. But you mentioned here 100% is possible to kill. The literature don't say, don't approve this statement. And second one is, do you think only the killing of coliform is enough for human health or food safety? Because we know there are so many pathogenic bacteria in leafy vegetables, like other than E. coli, bacillus, and many other pathogenic bacteria available. So do you think if washing is effective for human health for consumption of leafy vegetables? And another one is the performance of this system for foreign and chemical methods is not so satisfactory because it's a range of 54 to 60%. Considering these things, what you're thinking this method is actually effective to apply in the commercial area. Thank you very much.
One by one, I think.
My first question was actually, it's not possible to destroy any bacteria 100%. Another question was, is there any other pathogenic bacteria that is possible to wash by this method? Thank you.
Understand, I try to make sure if we understand your question correctly. So your question will be, is it why it is 100%? Is it?
Yes, right.
No,
Yes, why it's 100%?
And the second question is the
There are so many
method-
pathogenic bacteria in leafy vegetables, not only coliform bacteria. Why that bacteria is not considered for this experiment?
Alright.
Why here take the coliform separate from the bacteria? Why they separate the coliform from bacteria is because the coliform always become indication of disease, and always we detect the number of coliform on board, and we can will decide that it's not whether it is suitable for people to eat. So it takes the individually to talk about it. Did that answer your question?
Yes, another one is, I think the 54 to 74% removal of foreign material of hazardous chemicals is not so satisfactory, I think, because it's also harmful for human health.
If, for the rate of the removal of foreign materials, you mean that's not satisfactory?
Yes. Yes.
We say the foreign materials. And maybe yes, in this part maybe other methods to clean it more. Yes.
I think there can be used warm water to increase the rate of foreign material in this system. Warm water or little bit hot water initially. Okay, thank you for your answer.
Okay, so one small
Thank you.
question. You said best washing time, lettuce and failure is take 5 minutes, and plus Chinese cabbage take 10 minutes. I wonder what makes difference for what surface, what size of product.
And it is because for the leaves of lettuce and perilla are more softer than flat Chinese cabbage, so it takes less time to wash.
Thank you.